Yeah, tonight. I got a red eye. I think they must have a curfew from like midnight till 5, because this flight leaves at 11:57.
Hey, so I'm going to be up your way this summer.
Are you?
Yeah, I'm going to go up through Niagara Falls. We'll go up to Corning, do Niagara Falls, go into Toronto, go across to Ottawa, hit Montreal, come down, go into Boston.
Oh.
Any recommendations for me while I'm up there?
Oh, yeah, I could make all sorts of recommendations. Have you got a card? No,
I do.
Yeah.
I do.
I'll give you one of mine.
Thanks, John.
Okay, let's go ahead and get started with this afternoon session if we can.
Definitely.
So just kind of to recap what we've done today so far, we had some good opening words, and then we had a kickoff with Greg DiLoretto, and he talked about the infrastructure report card and kind of the dire straits that we have here in the U.S. and really some of the things that ASCE takes a look at. So it was kind of a national picture. Our panel with Hans, Vladimir, Craig, Andrea, and Colme talked about really from a municipal perspective where we are, and I thought the panel was very, very good because it showed some of the different approaches and so on as that. This afternoon we're going to shift our focus a little bit, and we're going to have two speakers, one who's going to really talk at a national level from a freight perspective, and then another who's going to talk really looking at the underground infrastructure component of this and how that fits in with geospatial information. I did want to say a few words. I was thinking as we went through the session this morning on a couple of things that kind of fit back into my career. About 2 weeks ago I was in Beijing and attended and participated in a conference at the Beijing Municipal Commission of Transport, which oversees all of the transport within the city of Beijing, 23 million people. And we were talking about mega cities, and it was pretty fascinating. One of the things we got to do was to go into their control center for the Beijing transport. And I've been on the floor at NASA's Mission Control in Houston, and this was about the same. About 30 meters by 30 meter room, 70 people sitting at different monitors, a 30 meter long by 15 meter high monitor broken up into all kinds of views all over the city, looking at subway, bus transport, highways, connected to 60,000 CCTV around the city. They could look at anywhere in the city and so on and so forth. It was pretty impressive. Had all these statistics, graphs, so on, floating around. And I'm sitting there going, there's so much information that it's almost like you're blown away, right? You're just like, what's going on here? And so when we finished, I asked a question. I said, so the lady who was actually running the center, and I said, you know, through a translator, I said, so you've been running now for about 8 years. I said, has congestion gotten any better? Has your traffic improved? And she kind of looked at me and asked a couple of questions and then said, no. And I said, so what do you do with this data? And so they're data collecting, and they send it out to all these different places. And one of the things I heard earlier today is this whole idea of data overload, or really information overload. We don't use it for what we're doing. One of the concerns they have is that their subways are not married up with their road network. They flooded the market with these day rental bicycles. It's reduced their bus ridership and so on and so forth. They're facing the same problems that everyone else is in terms of trying to get people from their place of residence to their work zone and doing it in a manner that provides for a quality of life. So it's pretty fascinating listening to all the stuff about all the data that we have, and at some point you got to use it. The other thing that kind of strikes me as I'm listening here, one of my background really is looking at project plans, and early project planning is really the focus that I've had in my career. And the better plans that we do are the ones where we have the right information. And I think that really gets down to information, particularly for infrastructure projects around utility adjustments, right-of-way information, soil conditions, environmental conditions, jurisdictional requirements, permitting requirements as we cross jurisdictions and so on and so forth. So I'm really interested to hear our speakers today, because I think what they're going to talk about is another set of data that might help us in that early planning for project component. So let me introduce our two speakers today. Ed Stracco is the Director of the Office of Analysis and Visualization, Bureau of Transportation Statistics at the U.S. Department of Transportation. He's co-chair of TRB's Freight Planning and Logistics Committee, and he's very much into this idea of national data, particularly, and I think he's going to talk a lot about freight today and talk a little bit about what his organization does. Our other panelist is Jeff Zeiss. He's the principal of Between the Poles. He has more than 20 years working in the geospatial software industry. From 2001 to 2012, he was director of utility industry, or the utility industry program for Autodesk. And both of these guys have won a number of awards. So I think we've got a really interesting, kind of contrasting set of presentations here this afternoon in terms of this. What we're going to do is we're actually going to have them each give a 20 to 25 minute presentation, and please hold your questions, and then we'll have a panel discussion at the end, and then we're going to have a workshop where we get you guys to work a little bit as we finish that as we go. So without anything further, I'll turn it over to Ed.
Thanks, Ed. Appreciate it, and really great to be in here. Thanks for the invite. It's great to be out of DC, and it's really great to be part of this really important conversation, be participating in this dialogue today. Let's see here. We loaded up here? All right. All right. Can we go back a little bit there? All right. So I want to touch on a couple of things. The BTS interest, why we care about this so much, some of the opportunities and challenges, really focus on the current ones, and talk a little bit about emerging, and then some solution sets. So let's get going. So BTS, we're part of the federal statistical community, or 13 principal federal statistical agencies. Census is the biggest, we're probably the smallest. We have a huge mandate though, but what this means for us as a statistical agency, we're providers of objective, policy-neutral, independent data for policymakers to make decisions, and that's really critical. We also have special protections that we can give data that other agencies can't. We can protect it from Freedom of Information Act disclosure and also from subpoena disclosure, so we're able to offer that to some of our partners. In addition to that, I mean, we just tell the story of transportation through data, statistics, information, and maps. We also have a couple other functions. National Library, we house as a repository all the research done on transportation, specifically the federally funded ones, but also funded by other folks. And we're also getting into data repository, looking at partners, how we have clearinghouses, how we work with universities on that as data comes along, and geographic data. And the last part there is it being a geographic data agency. And one of our mandates is to coordinate the national geospatial data assets in transportation, and also we take care of the National Transportation Atlas database. We're mandated to put that together. It's multimodal. We're looking at the extent, the condition, the performance of the system, how the system interacts with people, society, the environment, and the economy, how goods and people move over the system, how they flow over the system, how vehicles, how crafts, how vessels move across the system. And we have to be able to have the ability to do multimodal analysis on there. So we have about 70 data sets in there now, national level, cover the spectrum. Most of them are compiled. We have a couple that we create, but most of them are from others. All right, enough about us. It's a good setup there. So current opportunities and challenges, a number we could talk about, but the one I think is most apropos for today is freight. We heard Greg this morning talk about the economic impact, and when you think about freight and you think about this country and how we've invested in infrastructure since the founding, when we've in the 1700s with the ports and the canals, in the 1800s with the transcontinental railroad, in the 1900s with the interstate highway system, with the air traffic control system, we've invested in our infrastructure for freight, and that's allowed us to be competitive. That's our competitive advantage. When we can't compete on wages, when we can't compete on some of the product costs, we can compete because we have a good, efficient transportation system. We can get things to market fast and cheaply, and our companies, our businesses can invest that capital in technology and expansion rather than on struggling with a transportation system. That's why it's so critical. I put together a couple slides here just to emphasize the point again. We have access to GPS data from a couple 100,000 trucks. We decided we wanted to geofence the Port of Baltimore. Port of Baltimore is a regional port, and it doesn't go everywhere. And also you have the truck drivers that go in there, they're dray operators. They have short haul. They don't go all over the country. But just looking at this one day, where did the trucks that were in the Port of Baltimore one day, where did they go? After one day, this is where they went. After 2 days, this is where that same sample of trucks went. After 3 days, they're going all across the country. After 4 days, see even more expansion. After 5 days, they're all over. This is interconnected. It does not respect political boundaries at all. It's why we need to think of it as from a national perspective. There are two pieces I want to talk about in the freight, and I think that they help this conversation along. The two efforts that Congress has asked us to move forward on. First is the National Multimodal Freight Network. This came out of the FAST Act. The FAST Act is our authorizing legislation for surface transportation. So Congress and the staffers, we talk to them all the time, and they get it. They understand the importance of freight. And so they've asked us develop this network, a multimodal network, and they want us to do it to assist in the prioritization of federal investment. They want it to be developed to assist states in directing the resources, in transportation planning, and supporting the investments to achieve the goals. They also said, within 180 days, come out with an interim network while you consider all these other factors. And this is probably the worst slide you could ever see, but it's all jam-packed in there, but it's good that it's jam-packed in there because it's all these things we need to consider. And these factors that we need to consider are tough. And we're not fully there yet. I think these kinds of conversations are going to help us get there to create that national multimodal freight network. When you look at these, the first four, the A, B, C, D, I'll show you. We've got some good sense of those. When we drop down to E and F, it starts to get a little complicated. Don't even know what the definition of energy exploration, development, installation, or production area is. Think of traditional areas, coal fields, or even shale plays. But what about here in Arizona? Well, solar manufacturing plant. Do we include that? What about the field out in the desert where we put all the solar arrays? Do we include that? What about wind, where we manufacture the turbines? Do we include that? And what about the cornfield where we put the turbines? Should we include that in there? Oh, by the way, that cornfield, last year it was grown for cover crops or grown for livestock. This year we're growing the corn for ethanol. Should we include that corn in the energy production? A lot of questions out there. As we drop down further in the list, we're getting into things that are really fine-grained. Some of the intermodal links, some of the intersections, things that somebody in D.C., 3,000 miles away, doesn't necessarily know about. And it kind of gets us down to J there, facilities and transportation corridors identified by multi-state coalition states, MPOs. One of the reasons that's in there is conversations we had with Congress over the last map they asked us to do. We just didn't have the data. We need more fine-grained. We need to know everything that's going on at the local level, and we can't do that. That's why we have partners. Everybody on that first panel, we work with them directly to figure out what's going on. That partnership is critical, and we shouldn't be trying to make decisions on our own. We need to have that conversation. And the other ones there, major distribution facilities, intermodal facilities, again, last and first mile. Well, last and first mile for freight, those are even, municipalities don't know them. They're the little roads from a physical perspective, but they carry all the freight to the rail yard. Nobody cares about them, nobody thinks about them, but they're the most important parts for the freight system there. I throw this up here. This goes back to those first couple things. We know about the volumes, we know about the tonnage of value at a high level. We have a national system, HPMS, Highway Performance Monitoring System. We collect and compile data from the states. This map, what you see here, red routes or segments of routes that have 8,500 trucks or more on average a day, and those trucks make up 25% or more of the total traffic. The yellow, 8,500 trucks or more a day, and the trucks make up less than 25% of the traffic stream. Green, trucks less than 8,500 trucks, but the trucks make up at least 25% of the traffic stream. And then the rest, the gray is less than 25% of the traffic stream and less than 8,500 trucks. And this is just for the national highway system. When we think about the nation's highway, we have 47,000 miles of interstate. We have 230,000 miles of this national highway system, the big roads. We have 1 million miles worth of federal aid eligible roads, and we have 4 million miles of public roads. We're just looking at this and trying to get a sense of where are those major truck routes. One thing I want to point out too, look at the Four Corners area and kind of look out from there. Look at US 40, look at I-70, go down, look at US 491, look at US 89, look at I-40, look at US 60, look at the state lines. Now, you know, it could be that things are changing there, but it could be that the states are interpreting our data code a little bit differently there. I'm not sure, but there's something going on saying we need some partners, we need some regional looking into of what's going on there. This is the most expensive map you may ever see. This is at least a $30 million map. It's probably closer to $100 million. All those sources on the right are what are needed to make that map. And this is a huge effort alone. Just look at the highway side here. We have the freight analysis framework powers this. We have the CFS as a commodity flow survey. It's a survey we do every 5 years. We survey 100,000 shippers. We get about 7 million shipments. We know what the commodity is. We know what the modes they go on. We know the origin and destination zip codes. We're able to combine that with energy data from EIA, USDA, Census of Agriculture data, transborder data, to be able to create this national picture. Where are the freight flows? So it's all these pieces coming together to create this national level map. When you look at the regions there, they're very broad regions. We need to get finer grain. We always get pushed on finer grain. For Arizona, we have 2 areas around Phoenix and then the rest of the state. Something like Pennsylvania, we'd have Philadelphia, we have Pittsburgh, and the rest of the state. We need to get finer grain. We need to be able to get down to the county level. We need to get to the zip code level to understand these. And that's really, when you look at all the stuff that Vladimir does, that level of detail, we need to partner with them. We need to match that up. We're good at the links between those nodes and maybe even telling what the nodes are, but what goes on in those nodes, we don't have that capability. When you think about even how the trucks move, so we're saying, well, there's a million tons of freight moving from LA to Chicago, and we're going to look at the volumes from that HPMS I showed you in the other one, and we're going to divvy it up between I-10, I-40, I-70. But that's not actually how the trucks go. You have a less than truckload operator, you're taking it from one place, you go into a terminal, and then you're consolidating stuff and going back out. So it's just a general sense of it. It's not actually how the trucks go. Not like a truck tour where you go to A, B, C, and come back. We're just having them go to A, to B, to C. So it's still not a great representation, but gives that national picture there. I mentioned the intra multimodal freight network. Until we can figure all that out, this is what we put out. And this is National Highway freight network. It's about 56,000 miles. It's Class 1 railroads, about 90,000 miles. It's the top 50 airports by weight of cargo. It's all the inland waterways, and it's also ports that have 2 million tons or more going through them every year, plus a couple other things. So this is a start, at least what some of the bigger infrastructure is. That's enough of that. Let's talk about port performance. A couple years ago, you might remember we had a slowdown and a lockout on the West Coast. There are Christmas trees and other produce were rotting up in the Puget Sound area. Ships were queuing up in the Skag area, couldn't get in, couldn't unload the stuff for the holidays, so people started freaking out. So Congress said we need to do something. Congress asked us to pull a whole bunch of partners together, pull out the shippers, the carriers, laborers, port, and come up with some performance measures, come up with nationally consistent measures of the port's performance for the largest ports, top 25 container ports, top 25 ports by tonnage, and top 25 bulk ports. We didn't even have a definition of bulk ports. And report on the port capacity and throughput. All right, so we're looking here at what kind of data we have to put together. Now, don't have a lot of nationally consistent data. Every port's good at something. This port's the #1 at moving cars that are painted red. This one's #1 for importing bananas. Everybody's good at something. Very competitive space. Our friends at the Corps did have some data. Corps used to have a very robust program where they'd go out and had people measure everything, go out and measure the length of the berth, the pavement, and what kind of pressure, pounds per square foot you could put on it. We don't have that kind of staff anymore. So we tried to cobble together what we did for the first couple, and we've made some advancements, but a lot of that is just coming from websites and from calling up folks. No national consistency. Like the number of cranes, types of cranes, don't have anything nationally consistent there. And also acreage. Well, you'd think that'd be easy, but it's not so easy. Next one is related to that and some of the struggles we've had. So you have the on the left side, this is Port of Baltimore, left side there. We got to figure out what's what there. You see on the right part there is a container terminal. That big black thing in the middle is a pile of coal, a whole bunch of bulk stuff up and down. North of there, it's liquid bulk, has a bunch of containers. We don't know where the property boundaries are. On the left side there, you have Domino Sugar. They bring in big ships, and they store the sugar in big silos. They also package the sugar there. Well, what's part of the port? What's not part of the port? The right side there of the screen, we started to deal with the water side. Use AIS data, that's automatic identification system data. All ships of a certain size have these GPS type of locators, and get dwell times. How frequently are they coming into these areas at the berth, and how long are they staying? So we're making some progress, but lots of areas to go in. All right, let's talk about emerging opportunities and challenges. I think we hit on a couple of these already. Autonomous vehicles. When we see companies like the European car companies buying map companies like here, it makes us take notice. I talked to our ITS director. He thinks we only have 10% of what we need mapped to understand this. All the good work that's going on in Arizona for autonomous vehicles, we need to be able to move that across the country. We need to be consistent across the country and across Canada and Mexico. If we want cars to go across the U.S., we've got to make sure it's consistent, and we need a lot of detail on all of this. Related, Internet of Things and smart cities. You got the V2I, vehicle to infrastructure, but you also have a whole lot of other things. I think we touched on it a little bit before. We need that granularity. We need to be able to pull this data together to understand this if we're going to make the system work across the country. The last thing I want to talk about is CIM and BIM. We heard Tom talk a little bit about this right before lunch. This is the time to do something now before this gets ahead of us. As things are emerging, we want a robust marketplace, but we want standards, we want a framework. We want a metropolitan area to be able to look at these types of data and compare the state highway system, the county highway system, and the municipality all together, look at it. From a national level, we want to be able to understand what's going on quickly. A couple years ago, we had a situation with a type of guardrail that was failing. We had no idea where these were located or what the conditions were. Having a national repository or a series of national repositories and standards that we can look at are critical to this. This is a time to get ahead, to take bold action on all three areas I just mentioned. Don't necessarily want a central repository, but I think a federated set of repositories might be the bill. A great place for universities to come in. All right, solution sets here. My group is very small and getting smaller. My budget hasn't gone up in years. The world's changing around us. As a statistical agency, we're very concerned about data quality. We're having to reevaluate our relationship with data. I adapted this slide from USGS, crowdsourcing. I really like it because it shows the spectrum of how we can get citizen scientists involved. And when we think of everything from OpenStreetMap to Waze to Amazon Mechanical Turk to companies like Digital Globe and how they're using it, there's so many ways that we can get in there. And there are ways that we can have open systems. You have to have a .edu or a .gov address to participate, or it's affinity groups, the bicycling community, the transit community, folks interested in disabled access. A lot of folks who are really engaged, you can put them in different places. And there are ways to put checks and balances in there. We just need to think through that. Related is machine learning. On the left side, you see a project we're working on with Waze. We get all the Waze data from around the country. How can we leverage that to do some predictions? We're looking at this for crashes. They have an accident report. So can we use that to understand what the geometry is going on, where things are happening, and how to make changes? Sensors, remote sensing, areas we haven't really been too involved with, but other sectors have a whole lot of experience with. How can we adapt them? How can we have universities take these, be repositories, do the analysis, the data analytics that we don't have the ability to do, the computing power, the data scientists to do that. Also, adaptation of techniques. We've learned so much from the intelligence community over the years. What can we pull on the techniques there? And also outside our traditional communities. I put medicine and health. I've been talking to folks about retina scans, and the retinas, the capillaries in there are like networks, transportation networks. How can we take that technology from medicine and apply it to us? A couple partnerships that are really critical. Two good examples here, I-95, Mid-Atlantic Rail Operation Studies, 5 states, 3 railroads, 1 corridor coalition, don't necessarily like each other. They got together, they looked at their data assets, and came up with a consensus program on how to make the investments. Big thing on the East Coast is height of bridges for trains. You can't double stack them, that cuts your capacity in half. You've got to have all the bridges and all the tunnels on that line accommodate them. Having one that doesn't work. The other thing is North American rail networks. We brought together 3 or 4 national networks, improved the accuracy of them, partnered with the industry, adapted that as an industry standard, have an agreement with industry that we'll maintain part of it and they'll maintain part of it, so kind of a sharing of duties there. One last partnership here, a national address database. This came out of the need for an E911 system, some of the hurricanes. Get something that's open source in the public for everybody, bringing it up from the locals, Census Bureau and USDOT are working on this together. Lots of hurdles from different geographic coordinate systems to just licensing of the data. We've got 22 states engaged, but these types of partnerships are the future. The last thing, standards. You saw some of the issues with standards, not just having standards, but enforcing the standards, defining them is critical. It's very difficult for us to do national schemas, something we want to do, but we need help doing. I put up here one example I think is very positive, National Transit Map. 1990s, part of our mandate, do a national transit layer. We worked with the university to do it before the ink was even dried. Coming off the plotter is outdated. We didn't have the money to update this. All we did was update the fixed rail. Google comes along with the GTFS. Greg mentioned that this morning. We were able to work with the transit agencies. They're adopting that. The issue was everybody had different restrictions on it. We said, come to our site, click this box, say, let us harvest it, and agree to a Creative Commons license. Everybody's using the same license if you get it from us, so everybody has the same access to data. Incredible. We're able to do it quickly. We're able to do it twice a year. It takes us 2 weeks. We think you can do it down to 1 week, and we have top 25 agencies participating, 80% of the top 100, 300 overall, 500,000 stops, 60,000 routes. Tremendous. It's timely. It's the way of the future, we think. Thank you, and look forward to questions later.
Great. What I'd like to talk about specifically is things that are underground. So this could be sewer pipes, could be electric power, could be telecom cables, could be tunnels. There's a number of things. But these are all things that if you're going to dig a hole in the ground, you have to worry about. And the big, really big problem is that for the most part, we don't know what is underground. In other words, there's a real information shortage about what is underground. I'm going to give you some numbers about what that costs the American economy. And I'm also going to, hope to encourage you to think about this as a research area because this is really hotting up now. There is a lot of interest in this. And it's not only in the United States and Canada, but also in Europe and other parts of the world, because this is there's a few places in the world where they do have a fairly good database of what is underground. Japan, major cities is an example, and I have a list of a few other cities around the world, but this is a problem for most parts of the world. I was very impressed to see a recent paper from NGAC, which is a National Geospatial Advisory Committee, that not only showed infrastructure above ground, but showed a lot of the infrastructure below ground. And this is one of the first times I've seen a recognition at this level from a group of this importance, recognizing that we really do need to know what's underground. So let me just go through a couple of really important things about underground and our lack of knowledge about it. First of all, it's the #1 cause of delays in construction, highway construction projects. Okay, that's from the Federal Highway Administration. Second thing is that it is a billion-dollar drag on the U.S. economy. That $1.5 billion figure is from the Common Ground Alliance, which is a whole bunch of folks in the locate industry, construction industry, and whatever, who get together and do collect information. You can see in the fine print there that there was something like 390,000, roughly somewhere between 300,000 and 400,000 hits. In other words, during construction, a backhoe hit a cable or hit a pipe in 1 year, and there's some independent research that estimates that every time that happens, it's about $4,000. And so the total is about $1.5 billion. And the Common Ground CGA emphasizes that that is a minimum. And I will come back and suggest that it's probably closer to $50 billion to $100 billion a year. When you start including indirect costs, in other words, that's a direct cost. What does it take? What does it cost me to fix that problem? How much power has some customers lost during the time when the power was out? That's direct costs, but the indirect costs of having to redirect traffic or that kind of thing has been estimated as to be 30 times the direct cost. The risk to the public, everybody's aware of San Bruno. You might remember the El Paso gas problem. That, people are being hurt when this happens. So this is not just something, oh, it's too bad we hit a cable, some people don't have power. This is, oh, too bad we hit something and maybe some people are going to suffer for it. And the final thing I just want you to think about is that every time you build anything and you dig a hole, somebody does some locating. And we do it over and over and over again. Every time we dig up the road, the gas company comes out and locates things, the electric company comes out and locates things, and every time we dig up that stretch of road, we redo it over and over again. So it's something where one of the big problems is that we're not sharing information. And so I'm going to talk a little bit about a project in the Netherlands to solve that problem. Let me give you a real practical example. This is from Australia. This is the Sydney Light Rail project. It's an extension to the Sydney rail line. It's about 12 kilometers or whatever. Before they did construction, they spent a year going out looking through as-built and so on and said, oh, well, there's about 500 subsurface utilities that we're going to have to relocate. During construction, they found another 400. I mean, this just gives you some idea about how bad the information that we have about this is. They actually did a very serious study, a well-known consulting company, and estimated that that project could have been done, would have been completed 1.5 years earlier if they had had reliable data about what was underground. The project, of course, is still on time and everything else, and that's because contractors routinely build this risk into their estimates, both their schedule and also their cost estimates. This is the breakout for the 1.5 billion figure I mentioned to you before. You can look at these slides later in detail, but it breaks it out by telecom, natural gas, cable TV, and so on and so forth, and what it costs. It costs the amount, the cost. The direct cost is different depending on what type of thing you hit. And as I said, it does not include indirect costs. This is some research done in the UK that estimates that the ratio of total costs, which means social and indirect cost, to direct cost is on the order of 30-to-1. And if you take that, that means that we're talking about $50 billion drag on the economy, okay? And a lot of this is being paid by the consumer. And that's what this slide shows. And these are statistics, again, from the CGA, which showing that the consumers are basically carrying 30% of the cost of that. There have been some serious ROI studies that have been done on this. First one was done by Penn State and was sponsored by the Pennsylvania DOT, which estimated that for every dollar you spent improving the quality of what you had underground, you gained $21 and you saved $21. There was a study done in Milan, in Italy. For every euro you invested, you saved 16, and there was another study done by Purdue for US DOT that estimated something on the order of $5 for every dollar spent. So this is something where there's some good evidence that investing in this produces some returns. As I said, the research in this is accelerating. This is the first year that the CGA has released a Common Ground Alliance Technology Report. And this is a very interesting report because, first of all, it describes state-of-the-art for underground detection. I call this the last frontier of remote sensing. If you know about satellites and air photo and so on and so forth, how widely that's being used. Well, now we're beginning to get technology that allows us to do the same thing for underground. It also describes advanced technology that currently is being tested or deployed. And one of the really interesting things is where it also includes, it identifies gaps or opportunities where technology could help prevent subsurface. So if you're in a university or if you're thinking of a startup or whatever, here's a place where you can really get some ideas of some things that could be applied. In the UK, there's a project that has just completed that ran for 10 years called Mapping the Underworld that focused on geolocating things underground. It was about, I think, 10 million pounds or whatever, totally focused on universities. Now there's a new one that's basically the same type of thing, 10 million pounds, I think, assessing the underworld. And this is a lot of researchers getting involved in this project. This is a Smart London Infrastructure Network competition in London, in the UK, with some objectives of developing new technologies that could be applied for identifying things underground and identifying the condition of things underground. Just to give you some idea of what's happening from the private sector point of view, is this is Leica Geosystems, which is now part of Hexagon, has acquired IDS GeoRadar, which is a ground-penetrating radar company in Italy, to develop jointly technology that allows you to detect things. And you can see there's some really interesting concepts there. If you know anything about GPR, you know it's like walking around with a golf cart. I mean, you can go at about 1 kilometer an hour. So getting something up to 6 kilometers an hour is a big thing. And the concept of not only mapping what's underground, but mapping what's above ground is even more interesting. And that what you see there is a combination of LiDAR scanning above ground and ground penetrating radar below ground. Bentley Systems is one of the leaders in the software industry in engineering drawings and so on. and they have developed software specifically for 3D mapping underground. And Bentley had just reported at the last infrastructure conference a very interesting research project, just basically sticking 4 GoPros, you can think of this, 4 GoPros on a backhoe, and recording video and still of what they actually excavate, and that is being used, plus the location of surrounding buildings to accurately identify the location of underground infrastructure. And the idea is that you could do this without seriously impinging on schedules and budgets and whatever for construction projects. This is a really interesting thing. If you know anything about the ESA, this is European Space Administration. They've put up a satellite called Sentinel-1, which uses interferometry to accurately detect movements in the Earth's surface, and a very innovative company called Planetech is using this to help water companies identify where there are main breaks, where there's where there's breaks in the water system. Those are just some examples of some of the research that's going on there, but it gives you some idea of some of the activity that's going on there. The other area, a number of users have talked about standards. Another area that there's a lot going on is standards. The ASCE standard for underground is being around for a long time. It has 4 quality levels, pretty much determined by what kind of technology you're using to determine that, what's there. And that's been, like I said, this has been around for quite a long time. In France, it's just since 2012, is using a new one, which uses absolute precision. It's not something about, well, did I use GPR, or did I consult paper drawings, or did I actually go out and look for what's above ground that's visible, but said, you know, it's looking at identifying the location of things with an accuracy of 40 centimeters or 40 centimeters to 1.5 centimeters and so on. And PAS 128, which is the UK standard, kind of does both. It tries to use the A to D system from the ASCE, but also identifies B0 for B3, which identifies absolute precision levels. So there's some interesting things going on in standards. The OGC is working on a concept development study that's funded by the City of New York, National Center for Civic Innovation, and the Ordnance Survey in the UK, to put together some standards for data interoperability to allow us to share data interoperably about the underground. Stakeholders, there's a lot of stakeholders, funders, taxpayers, owners, and so on. I'm not going to go through this, but I'm going to pick a few and just give you some idea of what the benefits would be to have a national subsurface infrastructure map. For funders, especially private funders, and I'm going to come back to this, better financial returns. And this is going to be important because, as I'll show you, the amount of private money going into infrastructure is going up by leaps and bounds. It's dramatic how quickly that's going up. And that's money coming from pension funds, insurance companies, and so on. These folks want a financial return. So that means improving the quality of underground infrastructure can dramatically improve the efficiency of our folks that are building things. Taxpayers would get basically more bang for the buck. Owners, less risk and less cost. Public users means, you know, this kind of thing, the benefit would be fewer delays, faster projects. Contractors, less risk. Utilities and telecoms, faster outage resolution. The locate industry, the folks who go out there and find things, they would get rapid growth for at least the first decade because somebody has to go out there and find out where this stuff is. So I think if you look at the big players here, this is a big plus for all of them. I'll give you some idea of what's going on internationally. I mentioned that the Netherlands has something called the Key Registry, has just implemented something called a Key Registry for the subsurface, which means if you dig a hole and you find things, you've got to tell somebody about it. You've got to tell these folks about it. There's a lot of it. There's some issues relating to, you know, what standards are going to be used and whatever. It includes not just infrastructure that you find down there, but also geology. But they're serious about this, and I think this is going to be a remarkable breakthrough from the point of view of just sharing all this information that we're already collecting during construction. And France has a national program to map all critical underground infrastructure in the entire country to 40 centimeters or better. Okay, this is a national program. And if I'm a land developer and I need to go someplace, this is going to, I mean, I may choose France over someplace else because I know that I'll be able to identify where things are to reduce the risk. So I said I'd come back to funding infrastructure. Traditionally, governments and quasi-government organizations, and I'm sure you folks know a lot more about this than I do. But one of the really interesting things is that there's about $50 trillion in private funds out there. And that graph at the bottom shows that starting in around 2004, a lot of this money is starting to flow into infrastructure. It dropped after the 2007-2008 crisis, but you can see that, you know, 2007 was the previous peak, but you can see that in 2016 it's more than doubled that, and since then it's showing evidence to go up even higher. So that means private money means they're going to want to return. That means there's going to be a big investment in technology. It's going, as you can see, mostly into transportation, power, and energy, including renewable energy, but also into telecom, water. It's always been going into telecom, but also water, wastewater, and social infrastructure. But big places, transportation, power, and energy. And that means that efficiency is going to be, and improved productivity is going to be a big thing, and that's going to drive investment in technology. And that means R&D. McKinsey has done a report on construction and basically given some very good evidence that construction is one of the least digitized industries. It's down there with hunting. If you can believe it, at that level, and it really hasn't, and I could show you some productivity figures for many of the advanced economies, which said it's been flat for the 40 years. It really hasn't improved. So it is ripe for something to happen to it. And McKinsey, in another study, listed 5 key technologies. 2 of them are what I would call spatial, geospatial and building information modeling, or BIM. So the key takeaways, is that unreliable and incomplete information about underground costs the economy billions of years. I'd even say maybe $1 trillion a year. It adds risk to every construction project. It's a major drag on the economy, and it's a safety risk to the public. We do an awful lot of detection of this stuff already. We just don't share it, so we just do it over and over and over again. Cities, regions, and countries, as I said, France and Netherlands are realizing the benefits of knowing where things underground, and there's really accelerating research worldwide into technologies for detecting, mapping underground facilities and their condition, and there's also very interesting initiatives to advance the standards for sharing data about those. So thank you very much.
Okay, we have a few minutes for questions, so if you would like to ask a question, we'll get the microphone over.
Thank you. Have you heard of any incentive to get contractors to release the data? This is for Jeff. To release the underground infrastructure information that they've gathered for a specific project. They probably need to be incentivized. Have you heard of any programs or ideas out there on how to incentivize them to release that information to, you know, someone collecting the data?
Yeah, I have a list that I've just compiled myself of about 15 jurisdictions, cities, provinces or states and nations worldwide that have done something about underground. For example, Calgary in Canada, Calgary has bylaws that say that anybody who does any underground work in that jurisdiction has to provide, and this has been there for a long time, has to provide DGN files. I mean, this is back to the Intergraph days, you know. They have to provide DGN files to a consortium. It's a not-for-profit that just, and you can go there, and it's remarkable, and you can see everything underground. You don't have to provide any data, like telecoms in particular don't like, as you probably know, don't like providing any information about underground stuff. Utilities aren't much better. But you don't, all you have to do is say a yellow line means that telecom has something here. It's almost like what would go to a one call center, for example. That's one example. Tokyo and the major Japanese cities have had this kind of database for a long time, but in Japan you can do things like that. You remember we used to talk about corporate Japan. I mean, it was like Japan was one company, so you could do things. So there are, and I could give you 15 more examples of what people have done to try to make, to share this information, but they're exceptions, they're not the rule.
Good. Other questions? We have a question back here.
So in these other countries that do the underground mapping, who administratively owns that data? Who owns the process?
If it's a contractor that employs a locator to find it, the contractor owns it. And a contractor will, if a contractor's doing a lot of work in a certain area, if they can collect information about, let's say, an intersection, they've done work at an intersection before. The next time a bid, the DOT releases a project there, or asks for bids for that thing, and they have information about what's underground, competitively they've got an advantage, right? But how much of their work is on the same intersections that they did 10 years ago? So the answer is the contractor whoever pays the locator, that's who owns the data.
So I have a question following up on that. I know that, particularly using BIM, and I guess in the future maybe CIM for infrastructure projects, now with BIM, much of the review and testing and inspection data is actually filmed or videoed, and then the walls are closed up and so on and so forth, or you're putting in a slab and you know where the post-tension wires are or post-tension cables are. So, and that's being required by contract by the owner
right.
for the long-term purpose of the building. Have you seen any municipalities, cities, jurisdictions that have required that as part of say a road reconstruction project, or say a sewer line replacement or something like that?
That's a really good question, and the answer is yes. And the Oregon DOT, I had a chance to talk to Ron Singh, who was the chief of surveys at Oregon DOT, and he really foresees that what you're exactly talking about is going to change the whole construction project. He calls it turning the construction process on its head. Right now the process is you start a project and you send out surveyors as if nobody had ever been there before. They come back with some stuff, you do your design based on that, then you do you design and build your project. At the end, you put together a whole bunch of paper as-builts which go down the basement and nobody ever looks at again, and the next project in the same area starts off as if nobody had ever been there. What he's saying is exactly what you're saying. During construction, surveys with scanners and with the number, with the handheld scanners and whatever, you can scan anything now really quickly. A post-construction survey, right. And it goes into a database that would, and I asked him, so who maintains this database, presumably maintained by the DOT, and so that when another project happens in the same area, the DOT says, here's the data that we have already about this area. You don't have to send out a whole bunch of surveyors as if this had never been. You send out a few surveyors to ground truth what's there, and then you design you start with a lot more data than what you end. So you're accumulating better and better data, and he would foresee that in 20 years you would have an extremely good engineering quality database for all of Oregon.
Yeah. And I think that would work in a lot of other places as well. Yeah. Washington, do you have any questions for the panelists? We've got a question coming in, but we can't hear, so. Is that a technological issue? Is there any way to hear? His microphone is not turned on. Yeah.
Hey, there we go. Yeah, it worked. Right.
Recall public information about the location of high volume gas lines was well along for 9/11, and then Homeland Security said we turned that information into a reality that terrorists will get it. Is anybody really worried about that?
Yeah, good question. I think the question has to do with Homeland Security and high volume gas lines and those kinds of things.
Right. Yeah, I mean, I think a lot of the infrastructure in the United States is CPI. I mean, it's critical, there's legal laws, there's legal restrictions on what you can do with that information. But, it's just a question of who it can be shared with. I mean, I think that's, I think it would be very hard to crowdsource it in the way that OpenStreetMap does things, sending out a bunch of people with GPSs to locate that stuff, because that would probably contravene the critical infrastructure protection laws. But I think within the industry, the information could easily be shared. When you're talking utilities, contractors, builders, things like that.
Okay. Other questions? Yep.
I have one for Ed. I was really pleased to see the detailed level of the maps that you have. And I'm wondering, from the Department of Transportation's perspective, are you seeing it drive any conversations about prioritization and investment? Think about the Gateway project or the dredging requirements for the rivers to facilitate barge traffic. Are you seeing the maps that you have inform the discussion?
I think we have seen those, and I want to go back a couple years to the beginning of the Tiger program. So and the first Tiger were big discretionary grants we had a couple of years ago, and we've gone through 9 or 10 generations of them. Leading up to that, we used some of those maps and came together as a staff to talk about what areas of the country, different infrastructure had deficiencies at a meso level, I'd say. In the Pacific Northwest, we need to have more intermodal rail, or we have congestion in the Northeast on the highways, these types of things. And we got down a little bit more detail. We were able to show leadership some of those very first Tiger projects. I think you mentioned the Crescent Corridor. I think National Gateway was in there. That's another long rail project. A number of rail projects, the Colton Crossing, BNSF and UP out in California, Tower 55 in Texas. We were able to use those to say, we need to make these investments first, and then things will trickle down after that if we solve these bottlenecks. One of the things from the probe data, the trucking community, they put out a bottlenecks study every year, and they rank the ones that are most impactful of freight. So it's not just the most congestion, but the most trucks caught in that congestion. And in the Chicago area, we've seen the governor react to that and make improvements based on some of these maps.
Good. Got a question over here.
Ed, a question for you. I was struck by a slide you had up. I think you said you borrowed it from the USGS, but I'm wondering if you have examples from DOT that showed crowdsourcing as being on the spectrum of data collection all the way to sort of problem solving. And it struck me as very interesting that one could crowdsource data analysis and get toward that right side of the slide there with the kinds of data that you all use in transportation, of car sensors and traffic sensing devices on the freeways and stuff that we interact with every day as just regular human beings, not necessarily experts in the field. Do you get the sense that there is room for analysis even spatial analysis of data from volunteers who are out there, you know, kind of saying, wow, this is really cool data. Look at the things that I could solve, you know, if we basically, you know, hive mind analysis and solving problems.
Absolutely. And one of the things that we're seeing, and we're getting ready to go out with a challenge just in this area on the safety side. We're going to be asking folks to look at different data sets and then come back with their own analyses. What we're seeing is folks who are bringing different disciplines, cross disciplines, different sectors. They're bringing different perspectives to these data sets that we haven't seen. Maybe we're in blinders, or maybe it's the training we have in our discipline, but as we're really trying to reach out across sectors, both professional and civilian, to bring that in, and we've seen some very creative things. Now we need to look at them. Are these correlations spurious, or do they actually have something? But there's I think maybe even more growth there than in some of those other areas. And it's very exciting, and it's really kind of a game changer there.
Good, thank you. Do we have a question over here? We have one over here. So we got a microphone coming.
Yeah, for Ed, if I remember right from Greg's report card, of the 18 or so categories, the one that had the best score and trending in the right direction was ports. How much of that would you attribute to the Panamax ship ready as a catalyst? And do you have an idea of how many of our major ports are Panamax ready for the big ships?
Yeah, we've seen a number have been pushing to get dredged, and I actually think that there are more ports ready than actually can accommodate some of the ships. It's not going to, these mega ships, when you're talking 14, 17,000 TEU, and they're not going to stop everywhere. And so that might not be, although it's a good marketing point, is that what the reality is and where the investment needs to go. The other thing, when we look at the ports, and the deepening of the channels to get the megaships in, or the longer cranes to be able to reach those other stacks, that's one thing. But what we've heard from ports and from the governments around the ports, what's going to happen on the land side. So you're able to accommodate on the water side this megaship, but then you can't get the trucks or you can't get the trains in and out to move the containers. And so it's kind of pushing the problem. But also we need to look at it holistically, and that land side is so critical if we want it to be functional.
Okay, we have time for one more quick question. Anyone have one? Yeah, we got one right here in the front.
So just shifting gears a little bit, I haven't heard much, with the exception of maybe Tom speaking a little bit about hurricanes, about disaster recovery and resilience. And so I'm just curious about any conversations that are going on in those respects as we start thinking about a national infrastructure map or a national map of our underground infrastructure. I mean, I have to believe that Houston would have been a whole lot better off had somebody known about every little bit of every little thing in every little place as we sat getting 50 inches of rain.
Yeah, that is critical. I had a couple extra slides I took out that hit that point. Two examples on the crowdsourcing. For Puerto Rico, we do not have good infrastructure data on even where the roads are, anything about the pavement quality, about the volumes on the roads there. So we were in a tough spot. The university professor at Columbia University got together, and he got, I think, a bunch of OSM folks, and they went in and did a whole lot of mapping, and that's what the Red Cross and FEMA was using. Now, that's not necessarily the way we want to go with all of our resiliency, but it shows a new mechanism there. The other thing, when we look at it, there's a bridge. Another example I have is a bridge on I-40 in Arkansas. A couple years ago, White River washed it out. And so they did the little detour around there. But then we used some of the probe data, and we saw what impact it was actually having, and it was such a powerful example we were able to show folks that people were making decisions back in Texas and east of St. Louis on how they were getting around there. So it wasn't just that one exit to get around there, it was a third of the country, and especially those bridges and that middle line across the Mississippi, there aren't a whole ton there, is critical. Having that detailed information is definitely essential, and something that we think about. How do we pick that off, and which ones do we focus on there? The other one that I mentioned, the National Address Database, that was born out of the lack of information as well. The first responders didn't have any of the infrastructure or the addresses for the buildings, and so creating that national piece there for resiliency, a little bit different than actual infrastructure, but supporting those efforts was definitely critical there.
Yeah, and I would add, when it comes to underground infrastructure, that if you know where things are in 3D, and you have a digital terrain model, for example, you can identify every consumer that's not going to have electric power in a flood. I mean, it is not rocket science. It is so simple to do. The problem is that the data is so bad that right now the value of doing it is questionable. It's basically, if I know where the transformers are, where I know where the cables are, and I know what's going to be underground when I have a flood, 25-year flood or whatever. In North Carolina, I know they had statewide LiDAR, so they had a DTM for the entire state. They had another database with, I think, every building with 800 square feet or more, and they were using that to estimate the economic impact of a 25-year flood or 50-year flood, or a sea level rise of 50 centimeters or what have you. If you have an addition, an accurate database of where underground infrastructure is, which is typically the stuff that's flooded, you can come up with an even better estimate of what the impact is going to be, and really literally down to the consumer level. You know what transformer is going to be affected, you know which feeders are going to be affected, you know which customers are on that feeder. I mean, it's incredible what you can do with it. And what I find so surprising is that there's a national security dimension to this as well, and the fact that hasn't yet weighed in, knowing where things are for emergencies of various types. I mean, I think it's absolutely critical to know where that stuff is.
We're very reliant on locals. When something comes up, we have to make calls to get that level of information, and so it definitely there's a time penalty there. Related to the resiliency, there's often talk about truck size and weight regulations, and having, whether it's for resiliency purposes or just for efficiency purposes, as we look at can we make changes in those, both the length of trucks and the weight of trucks. From a national perspective, we're looking at corridor or we're looking at rerouting. We need to understand in detail the bridges, the geometry of those turns. Can these trucks actually make it? Even if it's just a utility truck carrying really long poles, or a really heavy generator or a transformer, we need to understand that at a high level. Now, those are state decisions that states do permitting, but being able to look at it from a regional and national perspective is critical.
Good. Let's give the panelists a hand. Good job. So we're about on the agenda. So we'll get back together at 2:45 for a discussion. A couple of ground rules there. If you're at a table We'd like to have 6 or 7 people at each table, so if you're at a table of 1 or 2, just find another table. We'd also like to split up the faculty a little bit. If the faculty are here, don't be in one table. So we'll get back together at 2:45. I'll give you a charge at that point, and we'll wrap the day up. Good job. Excellent. That was really good information. So what's your next step? I mean, it's trying to continue to push this forward.
See if we can get some of the folks from here interested, tackling some of this stuff. We just really need that partnership and the resources and the smarts of folks who are thinking about this in the university setting, definitely.
Okay, good.
So, yeah, I hope you guys will really think about this.
Yeah, absolutely. Absolutely. Thanks for coming down. And